Hello everyone, today me and my group is going to discuss about halogens. So what are the colors of halogen as they go down the group? For fluorine, it will form a pale yellow color. For chlorine, green yellow. Bromine, brown orange. And for iodine, gray black solid or purple vapor. They get darker down the group because their atomic radius increases, so therefore energy levels become closer and the low energy light is absorbed, making the colors darker. How about the melting point and boiling point down the group? The melting and boiling points down the group of halogens increases. As the molecules get larger, the van der Waals forces will also get stronger. Therefore, more energy would be required to overcome these forces.
Volatility of halogens going down the group. Volatility of a substance is defined as how easily a substance evaporates. As their shell size increases, there would be more electrons too, increasing the force of attraction between molecules. Therefore, it makes them less volatile as you go down the group.
Reactivity of halogens decreases. As we know, going down the group, the added electron shell will move further away from the nucleus, making the attraction force weaker. With this weaker attraction, it makes it harder for atoms to gain an electron. Therefore, reactivity decreases. Just like reactivity, electronegativity decreases. Electronegativity is the measure of atoms' tendency to attract a shared pair of electrons. Thus, it relies on the reactivity of each substance. Since reactivity decreased on the group, electronegativity decreased too.
The displacement reactions of bromine with sodium iodide with the help of cyclopropane. A more reactive halogen can displace a less reactive halogen in a displacement reaction. The chlorine atoms are more electronegative than bromine atoms, so they have a stronger tendency to form negatively charged ions. Bromine displaces iodide from an iodine solution.
In a halide solution, halogens can displace another halogen that is lower in the group. Since reactivity decreases down the group, a halogen that is higher in the group can displace another halogen that is lower in the group because it is more reactive, thus more electronegative, causing it to have a stronger tendency to form negatively charged ions. Thermal stability decreases down the group. Bond energies decreases down group 17, making it easier to break the hydrogen-halogen bond. This is because the iodine atom is the largest atom, so the overlap of its outer shell with the hydrogen atom gives it a much longer bond length than with the other smaller halogen atoms. The longer the bond, the weaker it is, and the less energy required to break it. Hence, hydrogen iodide is less thermally stable than hydrogen fluoride.
So what are the ways you could test for halide ions in a laboratory? First, you could add acidified silver nitrate, which is combining silver nitrate and nitric acid into a solution. If a precipitate is seen, it means halide ions are present. The halide ions will react with this acidified silver nitrate to form silver compounds, for example, silver chloride, silver bromide, or silver iodide. To see which silver compound is formed, we can look at the precipitation colors. First, if a white precipitate is formed, it means silver chloride is formed or chloride ions are available. If a cream precipitate is formed, it means silver bromide is formed. And if a yellow precipitate is available, it means silver iodide is formed. Another test you could do is by adding dilute ammonia and then concentrated ammonia. In diluted ammonia, chlorine ion dissolves while bromine and iodine ions remain insoluble. In concentrated ammonia, chlorine ion and bromine ion dissolves while iodine ion remains insoluble.
For number 10, the reason why sulfuric acid cannot be used to make hydrogen bromide and iodide is because they are both strong reducing agents and the acid will be reduced to sulfur dioxide. And for number 11, the reactions are shown here.
So what are the disproportionation reaction involving chlorine and sodium hydroxide with its conditions? The reaction is on the screen and you could take a look for a moment.
With that, thank you for listening.